Hello everyone, I am Monica from the Department of Computer Science Engineering. Today I am going to present a topic about Gauss seidel iteration method. Let us start the presentation. Gauss seidel iteration method. In this topic, we learn about the definition and introduction and basic idea and mathematical formulas how to solve the Gauss seidel iteration, and we can see the examples and advantages and limitations and conclusion. Definition. The Gauss seidel iteration method is a numerical technique used to solve a system of linear equations by improving the solution step by step. In this method, each variable is updated immediately using the latest available values, which makes it converge faster than the Jacobi methods. Introduction. The Gauss seidel method is an alternative method used to solve the equations of the forms Ax equals to b. It improves the solutions step by step until we reach the required accuracy. It is especially useful for large systems where direct methods like Gauss elimination become difficult. Basic idea. The main idea of the Gauss seidel method is solve each equation one by one, update the values immediately, use the newest value to calculate the next one. This helps the solution converge faster compared to the Jacobi method. Mathematical formula to solve the Gauss seidel iteration method. This is a modification of a Gauss-Jacobi method. We will consider the system of equations as a11x1 plus a12x2 plus a13x3 equals to, let it is considered as a b1, a21x1 plus a22x2 plus a23x3 equals to b2, a31x1 plus a32x2 plus a33x3 equals to b3. These are the equation 1. Where the diagonal coefficients are not zero and are compared to other coefficients, such a system is called dominant system. The system of equations are written as x1 equals to 1 divided by a11 into b1 minus a12x2 minus a13x3, x2 equals to 1 divided by a22 into b2 minus a21x1 minus a23x3, x3 equals to 1 divided by a33 into b3 minus a31x1 minus a32x2. Equation 2. Let the initial approximate solutions can be x1 power 0, x2 power 0 and x3 power 0. Substituting x2 power 0, x3 power 0 in the equation 1. Equation 1 of equation 2. We get x1 equals to 1 divided by a11 into b1 minus a12x2 power 0 minus a13x3 power 0. Let us it consider as equation 3a. This is taken as the first approximation of a x1, substituting x1 power 1 for x1 and x2 power 0, x3 power 0. In the equation 2, we get x2 power 1 equals to 1 divided by a22 into b2 minus a21x1 minus a23x3. It is a equation 3b. This is taken as the first approximation of a x2, substituting for x1, x2 of a equation 1 for x2 in the last equation of 2. We get x3 equals to 1 divided by a33 into b3 minus a31x1 minus a32. Equation 3c. This is taken as the first approximation of x3. The values can be obtained in a 3a, 3b, 3c constitute the first iteration of the solution, proceeding in the same way to get successive iteratives. x1 equals to 1 divided by a11 b1 minus a12 x2 minus a13 x3, x2 equals to 1 divided by a22 b2 minus a21 x1 minus a23 x3, x3 equals to 1 divided by a33 into b3 minus a31 x1 power k plus 1 minus a32 x2 k plus 1. Equation 4. The iteration process is stopped when decided order of approximation is reached or two successive or nearly the Same the final values of x1, x2, x3. So obtained consistive and approximate. Now we see the example problem. Now solve the system of equations by Gauss seidel iteration method. 10x plus y plus z equals to 12, 2x plus 10y plus z equals to 13, 2x plus 2y plus 10z equals to 14. First we have to write the given system of equations. Next, substitute the values in the equation. X equals to 1 divided by a11, b1 minus a12 x2 minus a13 x3. a11 means here 10, b1 means 12. By the we learned from the equation 1 we get the a1 values, b1 values and a13 values, a12 values. X equals to 1 divided by 10 into 12 into y minus z. Let us consider as a equation 1. Then next find the y value. Y equals to 1 divided by a22 into b2 minus a21 x1 minus a23 x3. Y equals to 1 divided by 10 into 13 minus 2x minus z. Equation 2. Z equals to 1 divided by a33 into b3 minus a31 x1 minus a32 x2. Z equals to 1 divided by 10. 14 minus 2x minus 2y. Equation 3. Let us start the iteration 1. Let z equals to 0 and y equals to 0. Substitute z comma y in equation 1. X power 1 equals to 1 divided by 10 into 12 minus 0 minus 0. X power 1 equals to 1.2, we get the x1 value. Later substitute the x equals to 1.2 comma z equals to 0 in equation 2. Y power 1 equals to 1 divided by 10 into 13 minus 2 into 1.5. We get the y value 1.06. Substitute x equals to 1.2, y equals to 1.06 in equation 3. Z power 1 equals to 1 divided by 10 into 14 minus 2 into 1.2 minus z into 1.06. Then we get the z power 1 value equals to 0.95. Now take y1 equals to z1 initial or internal values to get the iteration 2. Iteration 2. Put y equals to y power 1, z equals to z power 1 in equation 1. X power 2 equals to 1 divided by 10. In previous we get the x1 value and z1 values, that value substitute in the equation 1. We get the x2 power value equals to 0.999. Then later substitute the x power 2 comma z power 1 in equation 2. Then we get the y1 y2 value 1.005. Now substitute the x power 2 in comma y power 2 in equation 3. Then we get the z power 2 value 0.992, where x power 2 comma y power 2 comma z power 2 are initial values to get the third value. Now we start the iteration 3. Let substitute the y power 2 and z power 2 in the equation 1. Then we get the x power 3 1.00. Next substitute the x power 3 comma z power 2 in equation 2. We get the y value 1.00. Next substitute the x power 3 y power 3 in equation 3. Z power 3 equals to 1.00. These values are tabulated as follows. The above values are tabulated as follows. We consider the variables like x, y, z. In iteration 1, we get the x1 value as a 1.2, y value 1.06, z value 0.95. In iteration 2, we get the 0.999, y value 1.005, z value 0.992. In iteration 3, x value 1.00, y value 1.00, z value 1.00. Advantages: easy to understand, faster convergence than the Jacobi's, useful for the large systems and requires less memory. Limitations: works only if the matrix is diagonally dominant, convergence is not always guaranteed, slow for some systems. By the conclusion, the Gauss seidel method is a powerful and simple iterative technique to solve linear equations. It is widely used in engineering, physics, and numerical simultaneation. Thank you for watching. I hope you understand the Gauss seidel method iteration. Thank you.